For onto transformation, so we can see that both these rows have the pivot positions. So this will be an onto transformation. So for the third case, if we have a matrix something like 1, 3, minus 1, 0, and then 3, 3. For this n is greater than m. That means there are actually 3 rows and 2 columns. So it cannot be onto. Okay, cannot be onto. So it means that we can consider we cannot consider the one-to-one transformation when the number of rows are less than number of columns, and we cannot consider the onto transformation when the number of rows are more than the number of columns. But how about one-to-one transformation? So for this we need to convert this into the echelon form. So if we have this 1, 3, so what we can do is we can take the row operations like row 1 plus row 2, that will be row 2. And then we can take row operation minus 3, row 1 plus row 3, that will be row 3. So in this case what we will get is 1, 3, then 0, 3, and then we will get 0 and then 3 minus 9 is minus 6. So here we can see that we have this. Okay. So in this case we can see that each column has the pivot position. So for example, first column has this number position 1, and the second column has also the position 3. So this will be a 1-to-1 transformation. Okay, this will be a 1-to-1 transformation. Okay, our next question is find the matrix A such that the linear transformation is given by Tx is equal to Ax, and how it is given by? It is given by x1, x2, x3 is equal to 2x3 minus x1 plus 2x2, then x1 plus x2, 2x3 minus x1 plus x2. Okay, so it's minus x, this is x1, and then it is 3x1 minus 5x2 minus 3x3. Okay. So we need to find A. So we can we can rearrange the term and we can write it like this. Okay. So minus x1 plus 2x2 plus 2x3 and x1 plus x2 and then 3x1 minus 5x2 minus 3x3. In the second row there is no x3 term, so we can write like 0x3. Okay, so now going backward, then we can write it like this. If it is we take it as x1 as common from here, so we can write it like this: minus 1 1 3, a vector like this, and then plus x2, we can write it like this: 2 1 minus 5, and then plus x3, so we can write it like this: 2 0 and 3, 2 0 and 3. And then we can also write it like this: minus 1 2 2 1 1 0 3 minus 5 3 times x1 plus x1 x2 x3, that vector. Okay, so in this case then we get the vector A like this. Okay, so that is the thing. So if we want to get the vector A, so this will be the vector A.